Let's look at this example. In this example, we've got a sign that weighs 725 newtons. And it's got a cable A, that labeling A there, that's holding it, and a metal rod B. We can still consider the force applied by that rod as a tension force because it's staying straight and it's applying an equal force at both ends. It's transmitting all of the force with no loss. So even though it's not technically a rope or a cable, we can still, for this situation, count it as a tension force. So the first step is always to draw our free body diagram. And here's my sign. And our problem tells us that the force due to gravity is 725 newtons. We also have FTA, the tension force by cable A. And I'm going to use A instead of 1 and 2 on this problem just because the question itself gives us A and B. And we also have the force from rod B. And most of you, when you draw this, are going to do this. But that's not actually correct. And if we break out our tension force A into X and Y, I think it will make more sense. So if we break this into X and Y, and I'm going to draw Y first instead of X so that it's not on top of this. So FTAY and FTAX. There's my right angle. This angle is 30 degrees, so this angle is also 30 degrees. Now we can see our FTAX is pointing this way. We know that this is hanging motionless, which means it's in equilibrium. That means that this X and this X have to cancel each other out. That means that our FTB has to point this way, or we could draw it like this. FTB. Now, if you drew it pointing in the wrong direction, your math is still going to be correct and your answers are still going to be correct. But I know that some of you would have noticed this and not understood how this sign hung motionless. So I wanted to make sure that we could look at it and tell the direction of that force. Let's talk about what we know based off of what we're given in our free body diagram. We know that the object is at equilibrium, which tells us that the sum of the forces in the x direction is equal to 0. And the two forces in the x direction are FTAX and FTB. And we've talked about this a little bit when we were talking about the direction. So we should know that FTAX equals FTB. So we know now that when we want to solve for FTB, we need to get the x component of our tension in Y or A. We also know the sum of the forces in the y direction is equal to 0. This means that FTAY equals force due to gravity, which also means that FTAY equals 725 newtons, because we know this up here. Now we can use this y component and this angle in order to find our other two sides. I'm going to just sketch our triangle down here. If you prefer to draw it on your free body diagram, that's fine. I just try to keep my notes as clean looking as possible. We have FTA, FTAY, and FTAX. We have a right angle here, we have 30 degrees here, and we know that this side is equal to 725. We want to solve for the x component. We know adjacent, and we want opposite, so we're going to do TOA. Tangent of theta is equal to opposite over adjacent. And this tells us that our FTAX is equal to 419 newtons. And because of what we learned up here, we know that this is FTB, which is one of the forces we're asked to find. If we want to find hypotenuse, we would use our adjacent to find our hypotenuse, so we would use we would use cosine of theta equals adjacent over hypotenuse. And when you did 725 divided by the cosine of 30, you would get 837 newtons. That's our other answer.